In today's lesson, we are going to continue our intro to limits and looking further into estimating limit values from graphs. So the first part is, what is a one-sided limit? So in the last video, we were looking at a limit as, a function approaches an x value from both sides. And you can also look at it as just one side at a time. And we just have to add a little small detail into the notation. So I'm going to look at left side notation versus right side notation. So left-sided limit looks like this. It's the limit of f of x as x approaches a value a from the left. So it's like this little negative sign, kind of showing it's from the left. And then from the right side, you can probably guess what it's going to look like. The limit of f of x as x approaches a value a from the right. So you can have, looking at just the left-sided limit, or you could look at just the right-sided limit, or if you want to look at the limit of f of x as x approaches a, so not from the left specifically or from the right specifically. So if you want just at that value, what has to be true is that the left side has to equal the right side. So a left-sided limit could be different than the right-sided limit, but the limit at that value is only exists if the left side and the right side are equal. So let's look at these two graphs. First one, y equals 1 over x squared, looks like this. So what is the limit of the function as x approaches 0 from the left? So from the left, I'm getting closer to 0. It is approaching not a specific value, but it's approaching infinity. And then now the limit as x approaches 0 from the right. Okay, I'm approaching it from the right. Zoom up. Hey, that also approaches infinity. So because the left-sided limit and the right-sided limit are equal, the limit at that value as x approaches 0 is also positive infinity. Just a little side note, this is somewhat of a debated topic. Some say that it does not exist, that these do not exist because infinity is not a numerical value, but more of a concept. But know that infinity is what I'll use, and this is definitely accepted. All right, let's look at the other one. So just 1 over x. As the limit of 1 over x approaches 0 from the left, approaching 0, it's going to approach negative infinity. From the right, as I'm approaching 0, hey, well, that is going to approach positive infinity. And since the left side does not equal the right side, the limit as x approaches 0, this one does not exist. Now let's look at this piecewise function graph, and we're going to look at different limits. So we'll just call this f of x. So the limit of f of x as x approaches -2 from the left. So left, we're approaching -2. So from the left, we're approaching 1. Okay, so what is the limit of f of x as x approaches -2 from the right? Okay, so from the right, this approaches -2. So what is the limit of f of x as x approaches just -2. So because I'm approaching different values at -2, this limit does not exist. All right, let's do 3 more. I'm gonna write them down. Why don't you pause the video and then try them on your own. All right, so you should get, from the left it's approaching 1, from the right it's approaching 1, therefore as it's approaching 1, it equals 1. Now we're going to look at estimating limit values on a table. This function, let's see, there should be fraction bar there, and that's supposed to be x squared. And we want to look at the limit as x approaches 2. So I'm going to put 2 in the middle, and the idea is we want to think about approaching 2 from the left and from the right. First, let's think about what happens at 2. If you plug in 2, you get 0 in the denominator, so it's undefined at 2. So now let's just pick some x values, left of 2 and right of 2. Okay, so if we just use our calculator and we're going to punch in these numbers, we will get 3.9 and 3.99, 4.01, 4.1. So as x is approaching 2 from the left, y is approaching 4. And then as the x value is approaching 2 from the right, the y values are also approaching 4. So because the left and the right approach the same number, this limit approaches 4. Okay, last example. It starts out by saying the function f is continuous and increasing. So why is that important? If it's continuous, there's no discontinuity. There's not going to be a hole or a vertical asymptote or a jump in your graph. And when you have a continuous function with limits, you can just do a direct substitution into the function. So we have cosine of f of 2. Well, what is f of 2? Here we have the table for f of x. We don't have the actual value of 2, but as you're approaching 2 from the left and the right, the y values are both approaching 5. So we'll say this is cosine of 5. And now if we wanted to actually evaluate this, you can just plug it in your calculator. It would have to be in radian mode, and you're just going to get a decimal. So the decimal is 0.283662185. And this is just a quick discussion now about how to write final answers. So on the AP exam, they will only read up to 3 decimal places. You can always write more. They will simply only read 3. And you can truncate or round. Truncate means 283, literally cut it off and don't worry about rounding. So that is a correct answer. You could write 0.284. That is a correct answer. If you accidentally round and then round incorrectly, so let's say you write 282, that's now an incorrect answer. So to avoid making a silly mistake, I often tell kids, don't round, just truncate. And I even tell kids to go 4 decimal places just to be safe. 2836, that's 4 decimal places, truncated, and the AP readers will just read the first 3 and stop. So there is your full lesson, combining lesson 1.3 and 1.4, estimating limits from graphs and tables. Good luck.